one office up at the same time as the Desmos. You know what I mean? So if you hit this button here, you can make it smaller, you know, and then you can have this open at the same time, and that'll allow you to put the numbers in like easier. Yeah, go for it. So I hope you can start to gain an appreciation that, you know, if you actually plug in numbers, you could calculate these limits pretty close, but it's also a pain, right? Uh, 5 or 6 is good. I was trying to get away with 2, but it wasn't interesting. I mean, as a general point of order, keep enough decimal places that you can show the story of what you're trying to see, you know. So if I just did it 2 decimal places or even 3, I wouldn't be able to pick up on the pattern that I'm hoping to see here. Now for the next one, for part B, you can just keep 2 decimals. That's enough for part B. Interesting stuff happens at 2 decimals for part B. for the part B, 2 decimal places work. Yeah. Now for part C, when you get to part C, notice that A is not equal to 1 anymore. So you have to move the slider for A to 0 for part C. For part C, you're going to need to keep about 6 decimals again, because there's a .999 that's fixed throughout. The good news is for part D, you only need 1 decimal place. Really just 1 number. Ew. What is that? Oh, this is evil. It's just the foam block of the eraser, but it's got no eraser material whatsoever. It's a trap. Oh, here's the pad. Wow, that's sad. So, if you finished all the tables,
Yeah.
you move fast. I'm always going to be behind you.
What's going to happen if you don't finish today?
Then it's due next Friday.
Next Friday?
Yeah. There's still hope, though. Do not despair. So what I'm going to do at the moment is I'm going to work out those difference quotients, all right? So don't wait for me. Just go on, right? Or go back and finish parts if you haven't finished other parts before. Go back and finish those parts now while I'm doing this. Or you can watch me. It's up to you. So if we want to calculate f prime of a, what do we do? Limit h goes to 0 of f of a plus h minus f of a over h. So, right. So this is the square root of a plus h plus 8 minus the square root of a plus 8 divided by h. So this kind of problem, we're going to do that rationalization trick, right? So I will try the square root of a plus h plus 8 plus the square root of a plus 8. But this period, class period goes to 1:10 on Friday, right? So, yeah. I try not to use that in the regular lectures because, 2-hour lecture is not not ideal, right? How does this work out? You get a plus h plus 8 minus a plus 8, parentheses. The cross terms cancel, and for the sake of time here, I'm going to omit that algebra step, but basically the product of the square roots there, you get a plus, you get a minus copy of the same thing, and so they cancel out. And the square just gets rid of the square root, right? So you end up with this and that. Now notice that the a's cancel, the 8's cancel, you got an h left over, but then that h cancels with that h, and you're left with this. And so you guys can tell me what to do once I get to this. How am I going to, if I plug in 0, I can do that, right? This gives me 1 over two of those, right? So 2 times the square root of a plus h, 8 rather. Now, you can check it out. So we're claiming that f prime of 1 is what? 1 over 2 times the square root of 1 plus 8, which is what? 1 over 2 times the square root of 9, which is 1 over 6, right? Does that play well with what you found numerically in that table of difference quotients? What did you have, like 0.166? What is that? That's the decimal representation of what? 1/6, right? So, es bueno. What was the next one? One over what? X minus 2 squared. So if I calculate f prime of a, this time I'm going to use the x goes to a formalism. So we can calculate that as f of x minus f of a over x minus a. You have two choices whenever you're calculating the difference quotient. We can either use the h goes to 0 approach, or we can use x goes to a. Yeah, and so this one here, I got 1 over x minus 2 quantity squared, right? Minus 1 over a minus 2 quantity squared, all divided by x minus a. Now, so I make a common denominator, I think. I start to wonder if I'd use the h formalism if it would have been better, but oh well. So I've got a minus 2 squared minus x minus 2 squared divided by x minus a times x minus 2 squared times a minus 2 squared. So if I make a common denominator, I get this. Now, it's still type 0 over 0 at the moment. If you plug in x equal to a, we get 0 over 0. So I need to do some algebra to remove the indeterminacy. And what I have then is a squared minus 4a plus 4 minus parentheses x squared minus 4x plus 4. The 4's cancel. And what do we have? So the 4's are canceling. And looks like what I have there, limit as x goes to a. I suspect this problem would have been easier if I'd used h. Poor choices on my part. But I believe I've got a 4 times x minus a from this and that. And then I have minus parentheses x squared minus a squared. And so I can factor an x minus a out. I'm running out of board space here, so I'm going to make a kind of a sneaky step here. This is x minus a times x plus a. So I've got a common x minus a here and here, and so I can cancel the x minus a with the one downstairs. And when I do that, what I'm left with is 4x minus parentheses x plus a divided by x minus 2 squared times a minus 2 squared, which is what? Three x minus a over x minus 2 squared times a minus 2 squared, and that we can calculate the limit of. And what is it? We get 3a minus a, which is 2a upstairs. Hmm? Oh, one thing that was wrong is that should not be x, right? That should have been just a 4 because I canceled that, right? So that was what you're asking me about? Very good. So that should have been a 4. Yeah, so I have 4 minus x minus a, right? So what's that? Is that right? Do you see a mistake? Do you see a mistake? I think there's a mistake. Mm-hmm.
So how you factor it out is a squared minus 4a that you took out plus 4, right?
Yeah.
Then goes all over that is right.
Yeah.
From after it, right?
Yeah, let me actually finish. Maybe it's not wrong. I just am not believing it. You know, sometimes I um, just have to finish things. And so like when I plug in a, I get a minus 2 to the 4th power down here. And oh, yeah, I think it's right. It's actually right. Now upstairs we can factor out minus 2 times a minus 2. See that? Yeah, it's not wrong. I didn't recognize this 4 and the 4 minus 2a in the numerator is weirding me out. But I just need to stick with it because now I recognize the answer. It's minus 2 over a minus 2 cubed. That is in fact the correct derivative. There you go. And try plugging, so you can try plugging in a equal to 1. What do we get? Two. That's minus 2 over minus 1, which is 2. What did we get in the table? Values very close to 2. Yeah. So I think I inadvertently chose poorly here. I think if we'd gone with the a plus h formalism instead of x minus a, would have been easier. Every so often that happens. All right. What was the next one I was supposed to do? Sine of x. So f of x equals to sine x. This one so f prime of a limit as h goes to 0 of sine of a plus h minus the sine of a over h, right? And then the adding angles formula for sine gives me sine a cosine h plus the cosine of a times the sine of h minus the sine of a, all divided by h, which ends up giving me sine of a limit as h goes to 0 of cosine of h minus 1 over h plus the cosine of a times the limit as h goes to 0 of the sine of h over h. Now, at this point, we'll need to spend some more class time on these. We're going to come back to this one Monday, all right? Because it's actually a little bit tricky to prove these limits. We need a geometric approach to get these two, but you can work out, in fact, that this is equal to 0, and this guy ends up being equal to 1. And so the answer here, it turns out, is cosine of a. Sine of 0 is 0. So those are both indeterminate limits, and they require a geometric solution. And in fact, to be fair, the one that I assumed was 1 is the answer that I'm trying to, that we know it's 1 numerically. That's the table you worked out for part C. Shows that limit's 1, because you got 0.999. Yeah, you could, I mean, numerically you've seen it, but we should provide a geometric proof of that Monday. So anyway, plug in 0, cosine of 0 is 1, so it's consistent with your table. And then finally, for part D, you have f of x equals the absolute value of x, right? So that's either minus x or x. So when you calculate f prime of x, we either get -1 or 1 for x less than 0 or for x greater than 0. Which is what you saw in the difference quotient, right? You saw you got -1 when you're less than 0, and you got 1 when you're greater than 0. And so this is an example of a function. This is our first example of a function which is not differentiable, right? The absolute value function is not differentiable at 0. So you can either take a picture of the board. I won't erase anything. You can take a picture when you leave if you want, whatever. Take a picture now. It's up to you. It's also in the video, so you could screen grab it later if you want. What's that? Yep. One more? Oh, I did that one over here. I was lazy. Yeah. In fact, if you look at the difference quotient for this one, the limit as x goes to a of f of x minus f of a over x minus a. Oh, that's not what I want to say. Curses. We actually have already looked at that limit in class. We've looked at the absolute value of x over x before. So we've actually done the, f prime of 0 is the limit as h goes to 0, in this case, of the absolute value of h over h. We've actually looked at this limit in class already. We found it doesn't exist because the left limit's -1, but the right limit's 1. So, all right, let me move on. All right. Have you guys opened up Wolfram Alpha? So control click. Did I show you guys? I don't think I've showed you guys this yet, have I? So try it out. Like, once you guys got Wolfram Alpha open? Does everybody actually have a picture of this? Can I cover it up? I mean, I'll uncover it at the end of class, but. So, if you try something like, say, I don't know, Sine of X, and then just like do prime, see what it does. So if you look, it says d dx of sine x equals cosine x. This is notation for the derivative that we'll talk more about in upcoming lectures, right? So. Yeah, I'm talking about number 7. Oh, what's your question? You had a control click. Yeah, that's it. Yeah, now you got to put stuff in. So, like, try it out. So, for example, like sine of x prime, or you got it?
Yeah.
Did you hit prime?
Prime what?
Like that. So, Wolfram Alpha is actually. It's very, very user-friendly. You play around with it a little bit. You can solve many, many things. You can factor polynomials. Like, suppose you want to find how to factor, a particular polynomial. Wolfram Alpha is pretty good at it. Check this out, guys. Like, suppose I want to factor, x to the 4th minus 81. I just type factor x to the 4th minus 81, and here it is. What Wolfram Alpha is it's built over a program called Mathematica. It's like a user-friendly version of Mathematica. It's free, unless you pay for the pro stuff to see the steps. Of course, if you really want to see steps to calculus problem, there's also the Symbolab website, which does tons of stuff, right? I say this not because I want you to cheat, but because I want you to have a way to check your answers on my homework, right? If you do a differentiation, like the next upcoming stuff will have differentiation. If you want to check your answer, you could just go to Wolfram Alpha, put it in, and see what works out to see if you got the right answer or not. You know, it's very.
All we're doing is plugging in the equation from problem 5. to
Yep.
see if it
Yep. So you can try like the derivative of x plus 8, square root of x plus 8, see what happens. For example, see, derivative of the square root of x plus 8 is 1 over 2 times the square root of x plus 8. That's what I found on the board, but with an a instead of an x. If you want to put a instead of x, you could do like, I think if I did square root of x plus 8 prime of a, it might do it for me. I don't know. I haven't played around with it much. You can just put in purple. I tried it. It worked. I'll let that stand because we're kind of short on time here, so you don't have to take a screenshot of Wolfram Alpha if you don't want to. Mostly I want to make you aware of it. That's the point of this. So I'll loosen the. So problem 8, what I've asked you to do in problem 8 is to make graphs of the functions that we made the tables for, to see if you can understand the numbers that we found for the derivatives. But I also want you to graph the tangent line corresponding to each one of those points. So for problem 8, I say graph the tangent lines and the function, right? Yeah. Tell you what we're gonna do. I'm gonna stop here for now, and we'll pick this up next Friday. Don't worry about it until we'll finish this next Friday. I was hoping we could do it all today, but yeah, it's just not happening, right? So hopefully we'll spend another hour on this lab next Friday, I think. Hold on a second here. We're missing a person, though. I better not do that, because they'll just end up dragging the whole lab down if they show up. What's that?
We just have to plug the functions that you gave us in.
Ah, yes. Right, so we go to Desmos, and let's see here. We had what, y equals to the square root? I'll do the first one, square root of x plus 8. That's that graph, right? What's the equation of the tangent line to 1? It's what, y equals to 3 plus, what was the derivative we found? 1/6, right? Stupid. There you go. That's the graph of the tangent line. Now, how did I know that that was the tangent line? Where's that coming from? 3 plus 1/6 of x minus 1. This is the graph that corresponds to part A. So remember the tangent line? We defined it last class. It was y equals to f of a plus f prime of a times x minus a, right? So if we put a equal to 1, what do we get for this square root of x plus 8? square root of 9, square root of 1 plus 8, which is square root of 9, which is 3, right? And f prime of a, we worked that out. That was 1/6. And x minus 1, right? So that's the equation of the tangent line right there. Because with the point of we're looking at the tangent line to the point 1. We chose a equals to 1 for part A. That's where it comes from. Now, let me make this bigger here. So, again, we don't have time to do this. I mean, you're not going to have time to do more than like part A right now, right? But here's the picture of the square root of x plus 8, and also the tangent line, which is in green. Now, what did I ask us to do in the write-up here? I said make the tangent line dotted in blue and the function graph red. Actually, I have an idea. We can let me modify the lab a little bit. What we're going to do is we're just going to get rid of problem 9 in the lab. So we'll just stop at problem 8. That way, we'll just call the lab there, and then so you just turn in that much for lab 1. And I'll recycle this problem 9 in a later lab. We'll come back to it, circle back to it. Okay. That way, we don't have to use all of next Friday for a lab, which would be kind of counterproductive to the larger progress in the course. My apology, I've obviously made this lab a little bit too long. You know, I'm still getting used to things in here. So how would you make that graph dotted? Go to settings. What color was the function graph supposed to be? I said blue, so I got to click on that. The little, oh, not that. If you hit that, then I don't know. I don't ever remember exactly how to do it. Oh yeah, dotted line. I need to do that for this one, right? Click circle, and then you got your choice of dot, either that one, and it was supposed to be red, right? Did I say red? Red tangent line? Instructions? I think I said one was red and one was blue, didn't I? I said, make the function red and dotted blue. Okay. Did I follow my own instructions? I think I did it exactly backwards, right? Dotted blue for tangent line. There we go. I finally followed. There, I have followed my own instructions. Hooray. And did I say anything else? Did I say label the point of tangency? How do we do that? So you do comma, like in this case it's what? It's 1, 3, right? Label. And so point of tangency at, let's see, point tangency for I guess I have to put the, and we'll explore more about how we can manipulate these labels later, but there you go. If you don't like that being purple, you could change it to whatever color you like, you know. Like, I don't know, I like black for labels. So you just need to do that for the other, for part B and for part C. And just to take the mystery out of it, you don't have to do it for part D. Why? I mean, D, you just draw the graph and say, the graph for part D is the absolute value function, right? So what's the tangent line to the absolute value function at 0? This is absolute value, right? So what's the tangent line there? the answer is we don't define a tangent line there because f prime of 0 doesn't exist. F prime of 0 does not exist. In that table of values, you found -1 from the left, you found 1 from the right. They don't match up. The limit doesn't exist. Now, some people would say it has a left tangent, and it's got two tangent lines, like one goes this way and the other one goes that way, but there's no consensus on what to say there, so we say that there is no tangent line. Anyway. Does everyone feel comfortable finishing up through problem 8 for next Friday, before next Friday? I think some of you already have it completely done, if I had to guess. Am I right? You're done through problem 8? No? You only know what did I miss? But right. So I did it in marker up here, but you can use, if you look at that, there, all Desmos. I think that's easier, right? And so once you're done with all of that, you save it and upload it back to Blackboard, right? That you submit it to the assignment. Now I think I have the due date currently today at 1:30. That's not. I'll move it to next Friday. I was being optimistic that we would all finish today, so I was wrong. Listen, I will make sure that that future labs are much shorter than this one, so we'll hopefully all finish during the lab time. That is my intention. I don't really want these to drag on. So if I understand correctly, a lot of the other calculus sections, what they've done, it's not unusual. They'll just like, here's the lab, and just let the students work on them. So I may do that in upcoming lab meetings. And sometimes they're not due till like the end of the semester. I don't want to do that because then last semester I saw students who were working on all their labs from the whole semester in like the last 2 weeks, and like that's just it's not good for you guys to have it linger. And I'm hoping that we can enforce the concepts in the course as we go here. I hope that the difference quotient makes more sense to you after seeing this kind of numerical evidence today. May or may not be the case, but anyway, I shut up. Sorry, I went over.